I think that 2-point perspective is the most commonly used perspective system. I'm gonna show you how you can use it to start rotating things. And this doesn't just apply to drawing boxes and buildings. In the premium version of my Drawing Basics course, I'll show you how I use 2-point perspective to give my portrait drawings better structure. Imagine that you're looking through a window, and we can use the frame of this video as our window. Everything that you see through this window is what you draw on your paper, or within some rectangle on your paper. This is called the picture plane, and it's perpendicular to your line of sight. Your line of sight is just the direction you're looking, which is directly at me. The picture plane is perpendicular. It's this way. Technically, it doesn't have to be perpendicular, but then it gets all wonky and distorted, so just forget I mentioned it. So with 1-point perspective, we were looking directly at this plane. None of the edges are going away from us, so we don't have to converge any of them into the distance. But as soon as I rotate this box, even just a little, now this edge is farther from you than this one. When something gets farther away, it appears smaller. So we have to converge the edges of this plane to a vanishing point. The vertical edges stay vertical because we didn't rotate them this way. Every part of this edge is the same distance from the picture plane. So these edges stay vertical. Okay, so let's jump in and draw a box in 2-point perspective. The first thing I like to do is establish my horizon line, or at least think about it. We already learned this in the last lesson for 1-point perspective, so let's not cover it again. So there's my horizon line. And in this example, I'm going to distribute the 2 points evenly, just to see what happens. So they're gonna be here and here. And right in the middle, I'm gonna place the edge of the box. So 1-point perspective, we're looking directly at it. We rotated it. And now I'm gonna establish this edge right in here. It's the closest edge to me. And then from there, we're going to kind of expand out in each direction. So just for this one example, I'm gonna place this kind of in the middle between the 2 points. It doesn't have to be there, it's just that I'm showing you this one right now. Now, from these 2 corners of that edge, I'm going to extend these lines, this plane over here, towards this point. Same thing on this side. And I don't have to draw every line all the way to the vanishing point. I just have to imagine that if it continued, it would hit that point. Then I kind of cut these off. And now to establish the top plane, I just go from these corners that I have now, and from there converge it. And these are gonna start getting more and more horizontal. The closer we get to that horizon line, the more eye level things become, and they get more and more foreshortened. And so we're not seeing as much of it. So that's kind of a common mistake, is that as you get closer, you're supposed to flatten it, but people will just draw it up more than it actually should be to make it more of a square, because we know that the top of a box is a square or a rectangle. To see how this corner over here, from here to here, is very flat. It's almost a horizontal line. Whereas down here, it's very pointy because they're just farther away. If down here, it would be really pointy, really distorted. So we have all these converging lines, these 3 going to this vanishing point, and these 3 going to that vanishing point. Now the vertical axis, these are all perfectly vertical and they're parallel because we have not rotated our box down or up. So we have said that this is 2-point perspective, this is a decision we made, and the box is still parallel, it's facing the picture plane. We might still be above it or we might be below it, but it's still parallel to the picture plane overall. We haven't rotated it this way. And because this was in the middle, these 2 planes are equal. Now, what happens when we start rotating this box? What happens to these vanishing points? As we rotate the box, 1 point gets closer to the middle and the other gets farther. All right, let's get another picture plane in there. And this time, just to show you this as an example, I'm gonna make the horizon line a little bit uneven. It's going up, all right? So I'm gonna put the first vanishing point right here, and then the second vanishing point, I'm gonna put farther away. Let's just say it's outside of the picture plane that I'm drawing. And then instead of putting that box, again, between the 2 points, I'm gonna put it over here. And notice what I did here. I drew that edge perpendicular to the horizon line because I've now decided that my eye level, I am tilted. And so the ground is tilted. My whole world is tilted. So if I'm drawing a box that is on the ground, I have not tilted it in any way. I've only rotated it, spun it around on that vertical axis. If that's happening, then it's gonna be perpendicular to the horizon line, right? Because if you stand something up on the ground, straight up, it's vertical, right? If I do this, now I'm rotating it. So now what happens to these planes because the vanishing points are so different? This one's really close, this one's really far. So you see how this one is converging quite a bit. It's getting smaller really fast. This one is not getting smaller really fast. It stays, fairly parallel, just because it takes a lot longer for it to reach its point. So this one looks more like a perfect square. Not really, it's still converging, just less. So it's gonna be wider. Whereas this point is getting smaller and smaller, it's foreshortening a lot more. And so it's gonna be visibly a lot shorter. But the illusion is that these are actually the same. And it's because of this illusion that these are getting smaller, so they're moving away from us faster. So it looks like this is the same size as this. It's all an illusion. The whole perspective is just an illusion. Same thing with the top. As we rotate this box more and more, this vanishing point gets farther and farther away, and these edges become more and more horizontal, until eventually we reach the point where this plane faces directly at us, and the vanishing point is infinitely far away. The lines become parallel horizontally, and we're back at 1 point perspective. If we continue rotating it, that vanishing point jumps to the other side, and we repeat the whole thing again. So sometimes a plane is so close to facing directly at us, but not quite there, not quite perfectly horizontal, that the vanishing point is really far away. I'd need a sheet of paper like 5 feet long to plot that vanishing point. And it's actually very common for a vanishing point to be outside the borders of our page. Maybe not that far, but just like somewhere far enough that it's kind of impractical to even plot it. So here's a trick. You can create a unit grid on the edge of the page. Basically, if we did project the lines to a distant vanishing point, they would scale down proportionally as they go farther away. And if the edge of the paper was here, we can just figure out where the lines cross the edge instead of taking them all the way to the vanishing point. And we have an accurate grid that leads to a point really far away. So let me show you. So we know that at the horizon, the line will be pretty much parallel to the horizon, right? It leads to the vanishing point at the same angle. And then we have to make a decision of how much convergence we want kind of near the bottom, right? Like, where's the vanishing point? Is it somewhere over here, or is it farther away over there, right? And so if it's farther away, let's say it's like something like that, really far away, we'll just plot an angle somewhere low on our page. And then in between this and this, we just need to create convergence that all leads to the same vanishing point. And I already mentioned that they scale proportionally. And so if the halfway mark here is there, then the halfway mark, like right here where it crosses the border, is here, then we know that the convergence at this level is something like this. And then we can divide these in half. And if I want, I can keep going. I can create the same units above the horizon. So now I have a grid for how much convergence there is, and this grid is accurate. All these points lead eventually to a vanishing point that's far away, but I don't have to actually consider that far away vanishing point. I just need to follow this grid. And this is kind of a lot of lines. I could have maybe just put 2 in there, and that would have been enough for me to be able to visualize everything in between. Close enough. So now if I want to draw a box, and let's say one of the vanishing points is here, and the other vanishing point is really far away, like I plotted, and I want to put a box, say, somewhere here. Let's just put it like this, and I don't even need to put them on the lines. Let's just say the bottom of the box is actually right here, right? Not on one of these lines. Then I can still imagine a line in between these two. It's not that difficult. I mean, I can get really close. And then up, and then this one is right on the line. And then on the other side, this right plane is going to this vanishing point, and I can just estimate those angles pretty accurately because it's just right there. And let's just say this box ends right here. And then again, this angle here is going to be between this and this. And I will just estimate that visually. So this is a little trick that, if you are doing something that you're spending a little bit more time on, you can quickly plot these angles on there and set yourself up to be much more accurate. Eventually, you might get to the point where when you're sketching, you don't even need to plot things out. You just establish your horizon, and then you say, well, down here I have a box and the bottom edge is like this, and then you can kind of visualize that, and then you say, and then up here it'll be like that, right? And then that's all you need, and then anything you draw in between, you just say, well, I can kind of imagine that angle between these two and this angle, and then maybe this one's over here. And you can more intuitively do this based on just a few little cues that you put for yourself on the page. But it does help to practice this first so that you kind of ingrain this kind of thinking into your mind and it becomes more intuitive over time. Now, another common question that comes up during this is how far apart these points should be, or how far away are they from that object? And this is something that I'm going to cover in the next lesson in 3-point perspective, so make sure you're subscribed. And I think you should seriously consider joining the premium version of this Drawing Basics course. You'll get all the full lessons, projects, demos, and critique videos. That's at proko.com/drawing. Thank you for watching. I'll see you next time.